solving trigonometric equations, but we've got radians involved. So we have a look at this question. It says, find the solutions of these equations in the interval 0 to 2 pi. So that 2 pi bit will tell us that we're dealing with radians. If your angle is given in terms of pi, it's radians. So let's have a look at this first one. Sine theta is equal to 0.3. That one is pretty straightforward. We just need to make sure that we get all the solutions in our interval. So to do that one, we're just going to do sine inverse 0.3, and that will get us what theta is. To make sure that our calculator is in radians, so it has that little rad thing up there. Sine inverse 0.3, and we get that as 0.305. I'm just going to do it to 3 significant figures. So we need to find all the solutions in our interval. If it would help you, you might want to just convert that into degrees to think about where that would be on your sine graph, because I understand with degrees it's quite difficult to figure out what value that would be, because we're so used to dealing with it in degrees. So it's about 17 degrees. So 17 degrees, we said that was roughly equal to, so that's about here. So therefore, we've got that same gap there. So if we take that 0.305 away from pi, we'll get our other solution. So our other solution is going to be pi minus 0.305. And if you want to make sure you're getting the exact answer, what we can do here is I'm just going to delete that line there. What I can do here is then just do pi minus and then just the answer button. And then that'll give me the exact answer. And there we go. I get that theta is 2.84. Again, we're going to do it to 3 significant figures. And they are the 2 solutions that are in my range, because 0 to 2 pi, they're the only ones that lie within that region. So they are our 2 solutions. So let's have a look at question 2 now. 4 cos theta is equal to 2. So I'm just going to divide by the 4 there. So that will give me cos theta is 2 over 4, which is a half. So then let's just inverse cos that. So inverse cos of a half, we get pi over 3. So we get an exact solution there. So if you get an exact solution, please make sure that we are writing it as an exact solution. So pi over 3 is going to be somewhere on this side here. It's going to be smaller than pi over 2. So the other solution is down here. So that gap is the same. So I would do here pi over 2 minus pi over 3. That gets me that gap there. That gets me what that gap is. And I'm going to add that onto 3 pi over 2. There might be an easier way to get your head around that, but that's the way my brain works with this. And I like to use up the symmetry of the graph. And we get 5 pi over 3 there. So that becomes 5 pi over 3. So they are our 2 solutions within that range. Question 3 is 5 tan theta plus 3 is equal to 1. So let's make tan theta the subject. So that would be, let's do 5 tan theta is equal to 1 minus 3, so that would be minus 2. Divide by the 5, I get that tan theta is minus 2/5, like so. So let's then evaluate what that's going to be. Theta is minus 0.381 to 3 significant figures. Now, I need to find the solutions in my range, because that is not in my range. That's 0.381, because it's a negative. We want values from 0 to 2 pi. So we need to think about what our tan graph looks like so, and then it would just repeat. So we can see we've got our bottom tail here, so we need to go up. It's a bit hard to draw it backwards, I find. So we'll go to minus pi for now, because we need to figure out where this is on our graph. So again, if you want to, convert it into a degree so you know whereabouts that is. it's about minus 21 degrees. So that will be about there. So let's think about where that's going to be in our interval, because our interval is actually this side of the graph here, between 0 and 2 pi. So let's just go across. We're going to be here, and we're going to be here. So there are intervals. So, as you can see here, it's just repeating every interval of pi. So what we can actually do for tan is we can just add pi on to everything, so we get it in our range. So we need to add a pi to get to here and a pi to get to here. So let's do that. So let's do our minus 0.381, add pi to that. So that will get me one solution. So theta is 2.76 radians. And then we'll do theta is 2.76, add another pi on, because we know there's another solution within that range of 2 pi. So let's add another pi on, and we get that theta is 5.90 to three significant figures. So theta is also 5.90, and they are the two solutions that are going to be in our range. Okay, so let's have a look at this next example. So we are solving 17 cos theta plus 3 sine squared theta is equal to 13. So straight away, we might notice we've got cos and sine in here. Now, if we want to solve it, we really want to get it in terms of either cos or sine. So we might want to think about our trigonometric identities that we know involving sine, particularly sine squared. So hopefully we recall that sine squared theta plus cos squared theta is equal to 1. So let's rearrange that in terms of sine theta. So therefore, sine squared theta is equal to 1 minus cos squared theta. So now it's in terms of cos squared theta. I can then replace my sine theta there. So we'd have 17 cos theta plus 3 minus 3 cos squared theta is equal to 13. And then I'm going to put it in the form of a quadratic, because I can see that I've got a cos squared theta, I've got a cos theta, and I've got some numbers. So I'm just going to put the minus 3 cos squared theta here, and then I'm going to put the plus 17 cos theta, and then I've got my plus 3, and then I have to minus that 13 across, so that'll give me minus 10 is equal to 0. So in this scenario here, what we can do is we can basically solve this like a quadratic. And I might say, well, actually, I'm going to make cos squared theta. I'm just going to replace that with a y. And I'm actually going to make my equation, actually might flip the signs to make it a bit easier for me. So 3y squared minus 17y plus 10 is equal to 0. What you could do is you could also just put it into the quadratic formula as well and find a value for y. I might just do that. So 17 plus or minus the square root of 17 squared minus 4, minus 4. 4 times a, which is 3, times by c, which is 10, all over 2a, which is 6. So I get a solution that y is 5 when I do the plus, and then if I do the minus, I get that y is 2 over 3. But it's not actually y we're dealing with, it's actually cos squared theta. It's actually cos theta, I should say, not cos squared theta. It's actually cos theta. So let's replace our y with cos theta. So therefore, cos theta is now 5, and cos theta is now 2/3. So let's now find what theta is. So theta is going to be cos inverse of those values. In our calculator, you may find you end up with this. It'll say non-real error. So what we mean by that is, if we think about it, cos theta lies between 1 and -1 on our graph when we drew it before. So there is no cos theta equals 5, it doesn't exist. So we can just get rid of that bit, because cos theta can't equal 5, it can only equal values between 1 and -1. Focus on this bit here, so that cos inverse is 2 over 3. So cos inverse of 2 thirds is going to give me theta as 0.841 to 3 significant figures. So we again need to find all the values in our range because we need to find it between 0 and 2 pi. If you want to, just check what on earth that would look like in degrees if you are more comfortable with that. So that would be about 48 degrees, so that's going to be right here. So if we go across, it's going to be here as well. So what we can do is we can just add this difference on here. So I'm going to say that my other solution is 3 pi over 2, add whatever pi over 2 is minus that 0.841, because it's that bit of symmetry there that we want. Gets me a theta of 5.44 to 3 significant figures. And that is my second solution. So I have 2 there, 0.841 and 5.44. So let's now have a look at solving this equation here. So we have sine 3 theta is equal to root 3 over 2 in the interval of 0 to 2 pi. So here we're dealing with sine 3 theta rather than sine theta. So what we can do here is this. So let's say that theta we know is between 0 and 2 pi. What I'm going to do is I'm going to say that 3 theta I'm going to call x, big X. So then what I'm going to do now is I now want to find my range for big X, and then from there I can then convert it back. So I need to multiply all my, I need to multiply these values here by 3 because it's worth 3 theta. So 0 times by 3 will still be 0, and then and then 2 pi times by 3 will be 6 pi. So the range in which I'm going to look for my values now is 6 pi, and we'll talk about why that's the case in a moment. So let's say that sine of big X is root 3 over 2. Let's find what X is going to be by doing the inverse of that. So the inverse of root 3 over 2. X is equal to pi over 3. Now we need to look at the intervals in our range from 0 to 6 pi. So let's first of all draw out our graph of pi over 3 is going to be here before pi over 2. The other value in that range is going to be there. So that's be our values between 0 and 2 pi. So that means x is pi over 3, and then it'll be whatever pi over 3, whatever pi take away pi over 3 is, because I've got that gap there. It's also on this side of my sine graph here. So it will be pi minus pi over 3, 2/3 pi as my other solution, but that is only within the range of 0 to 2 pi. If I was to carry that graph on, it would look something like this. So if I do 2 pi and then 4 pi, so I'd have one wave, and then it's just going to repeat itself like so. So if we can see here, 2 pi, 4 pi would be the same. This would be pi here. This would be 3 pi. So it's just going to repeat now. These values, we can just add 2 pi to them until we reach our range of 6 pi. So I think we're going to get 6 solutions because we'll have some here. We're going to have some here. And then when it repeats again, we'll have, past our 4 pi here, we're going to get some here. And then we're not going to have any more because within our 2 pi range, we only have 2 each time. So we're going to take our pi over 3 and our 2 pi over 3. We're going to add 2 pi to those. So I end up with 7 pi over 3 and 8 pi over 3. So x is also going to equal 7 pi over 3 plus 2 pi, and it's also going to equal 8 pi over 3 add 2 pi. Give us 13 pi over 3, and it will also give us 14 pi over 3. So we have there 1, 2, 3, 4, 5, 6 solutions. But remember, these are for big X, and we said that big X is equal to 3 theta. Now we're trying to solve for theta, not 3 theta, so we now need to convert all of those. They're my solutions for 3 theta. So to find theta, I just need to take all those values now and divide by 3. So that will give me pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. And they now should be within our range of 0 to 2 pi. So think about the transformation of sine 3 theta. So that is going to be a stretch in x, and remember, it's for x we do the opposite, so it's going to be of a third, meaning it's going to get smaller. So all our x values we are going to divide by 3. So that basically means that we are going to have 3 times as many sine waves within 2 pi, because it's getting squished by 3. So we'll have 1 sine wave, 2 sine wave, 3 sine waves for sine of 3 theta. So that is why you're going to have 6 values. So the big X lets us just work with the sine or the cos graph, and then we amend that afterwards.